Now, to help you understand gravity, I'm doing this for a reason. There have been people that have talked about anti-gravity, some magic thing and this kind of stuff, and it's a very simple thing in concept. But I'm going to use graphics and some animations and some films of some of the tests we've done to explain gravity to you, so you understand then how anti-gravity can be made and was made, and will not be surprised when you see this upon you shortly out in the open. There is a real severe deception in the works, not entirely mankind's doing. Remember me telling you about noise level, guy out fishing and seeing the vortex and the little spin and stuff. What we see here is just a simple water drop. But I've put this up to show you how when the water drops, it splashes out, makes a large radius first ring, then smaller ones out like that. And then the reflection of its splash pops up a ball in the air like that. Okay, big deal, you've seen that. Now, what happens next is you will see if you take one splash, it sets equally, almost equally spaced crowns out like this. These are inertial things formed by water pressing on itself to make little beadlets out here like one single drop would do. This happens usually on a flat surface instead of a deep amount of water. Now, for the astronomers in the crowd, what we see here is a splash which can represent the sun. Then there's the first orbit of some planet, and the second and the third. But if you're an astronomer, you notice that those rings, the radii of them, do not match our planets. You think, well, this couldn't be explaining gravity and orbits of planets. Gravity can be determined with a telescope looking at distant star systems. How can you see gravity? Because scientists, astronomers have found that as a star spins, it's originally spherical, but as it spins, it starts to flatten at the poles. And this is called oblateness. It's not totally round, it's oblate flattening. When that happens, they measure the number of degrees of off-true circle that is, and they say, its gravitational constant is such and such because it is so flattened. The more it flattens, the higher the gravitational constant. What they're telling you is this: gravity has to have spin around some center or you don't have gravity. So you say, well, why is that? It's because gravity is not a one-way force. It's the result of two forces acting. You spin out, diverging, and where they cross partially or entirely, the directions either cancel entirely or are more in favor of this way or that way. In essence, gravity will reverse in orbits and not all be pointed at the sun. In between orbits, there are null zones. There are zones where the forces net more that way, out away from the solar system than toward the center. On the Earth, if you were to drill a hole all the way down to the center and drop a rock, it wouldn't go to the center of the Earth. It would go down a fixed distance and bounce back up, not to the surface, but probably 150, 200 miles below, and find its equilibrium point. There are layers or shells of inertia that form gravity. Spin. Have I lost everybody? Now, I don't have stock in Coca-Cola, but I sure use them a lot. This is the top. You'll see this in action in a minute. This is the top of a 2-liter bottle of Coca-Cola. I've developed a process of generating planets and stars with sound waves on the surface of a Coca-Cola bottle, with Coke in it, of course. Dr. Pepper worked as well, so if you're listening, Dr. Pepper. What you'll notice there is a depression. That was a strong hint, wasn't it? What you'll notice here is a depression on the surface of this liquid. Now, in school, you're taught this is surface tension that holds that little bead up. If you've watched rain fall down in a puddle closely, you'll see that splashes will hit a puddle and little tiny bubbles or spheres will dart around very quickly on the surface and then be absorbed and disappear.